Hello, and welcome to Somniora Mind. I'm glad you're here. Here's a paradox to carry into tonight's long, slow drift. Right now, without asking permission and without waiting for a single instruction from you, roughly 30 trillion cells are quietly negotiating your next heartbeat, your next breath, and your next hour of repair. So here are 3 quiet questions to fall asleep inside of. Why does a bruise sometimes hurt more the moment you actually look at it? Why can loneliness raise inflammation in your body, the same way an infection would? And what if health was never really about single decisions at all, but about something closer to a long, quiet conversation your body has been having with itself your whole life? Here's where we begin, with a fact worth sitting inside of. Every single one of your organs is holding a private, detailed memory of nearly every threat your body has ever survived. Let that settle for a moment. Not just your brain. Your immune system, too, carries its own kind of memory, quietly filed away, ready to move faster the second something familiar shows up again. Tonight, we're not going to rush through a checklist of symptoms and fixes. We're going to wander, slowly, through the living systems that keep you upright, thinking, healing, and resting, usually without asking for a single moment of your attention. Get comfortable. Let your shoulders soften into whatever is holding you. Let your breathing slow into something long and unhurried. This is a long, gentle road tonight, so there's no need to rush any part of it. When you're ready, let's step inside. Let's begin with that quiet memory itself, because it's one of the more remarkable things your body does without ever asking for credit. After you recover from an infection, part of your defense system doesn't simply stand down and forget. It keeps records. Specialized cells store the pattern of whatever they encountered, so a second meeting can trigger a faster, sharper response than the first one ever managed. That's part of why so many childhood infections rarely trouble you the same way twice. And it's also why a vaccine can offer real protection without forcing you through the full illness first. This learning isn't just about brute strength, either. It's closer to precision, swapping a wide, clumsy net for one very specific, well-made key. Over time, your body quietly builds an entire personal library of these microscopic records, one that shifts with age, travel, the seasons, even the people you happen to live with. Health, in that sense, is partly a story of lived experience. Your immune system simply happens to be the one still carrying that story forward, page by page, long after you've forgotten the details yourself. That same kind of quiet precision runs through nearly every corner of the body's defenses. Your immune cells aren't a single uniform army. They carry very different jobs. Some, like neutrophils and macrophages, are fast responders, rushing straight to an injury or infection to clean up debris and engulf invaders, closer to first responders than to historians. Others focus entirely on long-term strategy. Certain cells can be trained to recognize one very specific threat, then remain quietly on standby for years, positioned at likely entry points like the lungs and gut, waiting patiently in case that exact threat ever returns. Dendritic cells act almost like scouts, gathering evidence and presenting it to the rest of the immune system so the right kind of response can actually form. This division of labor is part of why immunity can feel both immediate and lasting at once. It also explains why, when immunity does fail, it's often not because one single cell type was weak. More often, it's because the coordination between all these separate roles quietly broke down somewhere along the way. Antibodies play their own very particular role inside that coordination. They're precision tools, built by specialized cells to physically stick to a virus or bacterium, almost like a small label that says, "Deal with this now." Some antibodies work by blocking a pathogen from ever attaching to your own cells in the first place, stopping an infection before it can gain any real momentum. Others simply tag an invader so the rest of the immune system can find and destroy it more efficiently, or trigger an entirely separate cascade of proteins that can punch small holes directly through a microbe's outer wall. After an infection or a vaccination, antibody levels often rise sharply at first, then settle back down to a lower, steadier baseline. That drop doesn't necessarily mean your protection is fading either. Plenty of other immune defenses often remain quietly ready in the background, even once the antibody count has dropped. In a sense, antibodies function as both shields and signposts at once. They defend you directly, and at the very same time, they quietly point the rest of your immune system toward exactly where it's needed. None of this defense would matter much without a solid boundary to defend in the first place, and your body's barriers are far more active than they first appear. Skin cells produce antimicrobial compounds capable of damaging microbes on simple contact. In the gut, a careful layer of mucus keeps bacteria separated from the intestinal lining itself, while immune cells stand quietly watching just beneath the surface. Tight junctions between individual cells act almost like small seals, deciding exactly what's allowed to pass through and what isn't. When these barriers stay healthy, they actually limit unnecessary immune alarms, which helps prevent the kind of chronic, low-grade inflammation that can quietly wear the body down over years. When a barrier gets disrupted instead, through stress, poor sleep, certain medications, or simple dehydration, the immune system often ends up facing a much heavier workload than it should. Barrier health rarely sounds glamorous, but it may be one of the most fundamental parts of the whole system. The quiet difference between an immune system that only responds to genuine threats and one that stays constantly distracted by things that should have simply been kept outside to begin with. Your gut microbes contribute to that same defense in a wonderfully simple way. They take up space. In many ecosystems, one of the easiest ways to keep invaders out is to leave no room for them to settle in the first place. And your gut works in a remarkably similar way. When beneficial microbes are thriving, they compete directly for nutrients and attachment sites along the intestinal wall, leaving far less room for harmful organisms to gain any real foothold. Some of these friendly microbes even produce acids or other compounds that make the local environment genuinely less welcoming for certain pathogens. This effect, sometimes called colonization resistance, helps explain why certain harmful infections tend to appear specifically after a course of antibiotics has disrupted the normal community living in your gut. The defense here was never really one single hero species working alone. It's closer to a crowd effect, where diversity and overall stability matter more than any single microbe ever could on its own. One more quiet reminder that health here isn't really about killing every germ in sight. It's about supporting an entire ecosystem healthy enough to keep trouble from ever finding a foothold at all. Vaccines work by quietly borrowing this same natural learning process, minus the actual danger. A vaccine is, in a sense, a rehearsal that skips the worst part of the play entirely. Instead of letting a real virus or bacterium run loose through your body, it presents your immune system with safe fragments or safe instructions and simply invites a practice response. Your cells learn what to look for, how to coordinate with each other, and how quickly they need to mobilize the next time. Some vaccines use weakened versions of a germ, some use purified proteins, and some deliver genetic instructions your own cells briefly read and then discard. The result is often a faster, stronger response if the real pathogen ever does arrive, which can meaningfully reduce both severe illness and long-term complications down the line. When enough people in a community are vaccinated, the ordinary chains of spread break more easily too. quietly protecting the people among us who simply can't mount a strong immune response themselves. A vaccine, in that sense, was never only personal protection. It's also a kind of shared, community architecture, built collectively out of countless small, individual immune systems all learning the same lesson at once. Sometimes, though, that same powerful learning system misfires in the opposite direction. In an allergy, your immune system treats an entirely harmless visitor, pollen, a particular food, ordinary dust, as though it were a genuine emergency. The body releases histamine and other chemicals that widen blood vessels and tighten airways, producing sneezing, itching, hives, or wheezing. In more severe cases, blood pressure can drop sharply and breathing itself can become difficult, which is exactly why a serious allergic reaction counts as a genuine medical emergency. Why allergies develop in the first place is still a genuinely puzzling question. Genetics play some role, and certain early life exposures may shape overall risk, but no single explanation accounts for every case. Some people develop an allergy only after years of complete tolerance, while others gradually improve with age instead. Treatments range from simple antihistamines to a slower, more deliberate process called immunotherapy, which carefully retrains the immune response using tiny, controlled exposures over time. Allergies, in their own strange way, are proof that immunity is powerful, but not always wise. Sometimes, protection itself needs to be gently taught a little restraint. Autoimmune disease tells an even stranger version of that same story: mistaken identity, on a very intimate scale. It happens when immune cells confuse the body's own tissue for a genuine enemy. Instead of attacking a virus, they turn instead toward joints, skin, nerves, or the lining of the gut. Symptoms vary enormously depending on the exact target: swelling and stiffness in some cases, rashes, fatigue, or numbness in others, and many autoimmune conditions wax and wane in flares that can feel genuinely unpredictable to live with. The underlying causes are complex. Genetics can raise overall risk, certain infections can act as a trigger, and hormones appear to influence timing, which is part of why many autoimmune conditions show up more often in women. Under ordinary circumstances, the immune system carries built-in checks specifically designed to prevent this kind of self-attack, but occasionally, those checks fail regardless. Modern treatments generally aim to calm the misdirected response without shutting down the body's defenses entirely, and researchers continue exploring ways to restore genuine immune tolerance, essentially teaching the body to recognize itself again. Autoimmune disease, more than almost anything else in this whole system, reveals just how much health depends on accurate recognition and not simply on raw strength alone. Let's rest here a moment. Breathe in slowly for a count of 4. Hold it. Let it go, slower than it came. Somewhere inside your body right now, a quiet library of memory is simply resting too, ready, but in no rush to be needed. Let's turn now toward movement and metabolism, because so much of what your body does with fuel and energy happens far faster than most of us ever realize. A few minutes of ordinary movement can genuinely shift your blood sugar in real time. When your muscles contract, they can pull glucose directly out of the bloodstream for fuel, even before your body leans heavily on insulin to manage the process. That's part of why a short walk after a meal can change what happens over the following hour. Rather than glucose lingering and spiking, more of it gets guided straight into working muscle, where it can either be burned immediately or stored away for later use. You don't need a marathon to see this effect. Climbing a flight of stairs, pacing gently during a phone call, or simply standing up and sitting back down a handful of times can nudge that curve meaningfully over days and weeks. This repeated signal can genuinely make your cells more responsive to insulin, which in turn lowers the ongoing strain on your pancreas. Movement, seen this way, isn't only about fitness in some abstract sense. It's real-time blood chemistry, quietly shaped by choices as small as whether or not you happen to stand up. Muscles don't just move your joints. Either, they actively communicate with the rest of your body while they work. When muscles contract, they release chemical signals called myokines directly into the bloodstream, capable of influencing organs far away from the muscle itself. Some of these signals support a healthier overall metabolism by helping the body handle fuel more smoothly. Others can gently nudge immune function and inflammation in a more favorable direction, well after the workout itself has ended. This is part of why people so often feel clearer and steadier after regular movement, even when their weight hasn't changed at all. It's also part of why strength matters for reasons that go well beyond simple appearance. Muscle, in this sense, is communication tissue, and the message grows stronger the more consistently it gets repeated, because your body slowly learns that movement is simply a normal, expected part of life. That learning can genuinely change how your liver handles fat, how your brain responds to stress, and how your blood vessels behave under everyday pressure. You might think of regular exercise as a kind of broadcast, every single contraction quietly sending out the same message: build, adapt, and stay ready. Bone responds to that same kind of signaling in its own patient way. Bone is living tissue, constantly being remodeled by two opposing cellular crews working side by side. One team steadily breaking down older material, and another laying down fresh mineral in its place. This isn't only routine maintenance, either. It's how bone actually responds to the physical forces of daily life. When you lift, jump, or even carry a heavy bag of groceries, the stress patterns created tell your bone exactly where extra strength is genuinely needed. When bone goes underused instead, your body can quietly reclaim some of that mineral, and the overall structure can begin to thin over time. This constant rebuilding also plays a role in regulating calcium levels in the blood, which matters enormously for both nerve signaling and muscle contraction throughout the entire body. Strength training, in particular, can genuinely help protect against future fractures, especially when it includes weight-bearing movement that challenges the hips and spine directly. It's a beautifully self-reinforcing loop. Stronger muscles create better loading signals, and better loading signals support stronger bone in return. Health, built this way, becomes sturdier not by accident, but through a long, repeated conversation between force and living tissue. That same conversation runs quietly through your blood vessels as well. Sitting still for long stretches of time can measurably stiffen blood flow, at least temporarily. When you stay seated for a long period, circulation in your legs slows, and the inner lining of your blood vessels receives less of the natural frictional stimulus that helps keep it working well. That lining is meant to sense flow and release relaxing signals that keep the vessel responsive and flexible. And with prolonged sitting, some studies show a genuine short-term drop in that responsiveness, especially in the arteries of the lower body. It's a little like letting a hinge sit unused for too long, then noticing it squeaks the moment you finally move it again. The encouraging part is that this particular effect reverses quite easily. Simply standing, walking briefly, or doing a few gentle calf raises can restore normal flow and remind those vessels how to flex properly again. Since modern life so often stacks long sitting sessions on top of each other, at a desk, in a car, on a couch, breaking up that stillness even briefly becomes a small, quiet act that keeps your circulation genuinely practicing its own natural elasticity. Even the timing of a short walk relative to a meal turns out to matter in ways that are easy to overlook. After eating, your blood sugar naturally rises as nutrients enter the bloodstream, and the shape of that particular rise can matter quite a lot for long-term metabolic strain. Research has found that breaking up sitting time with brief, light walking can noticeably flatten that post-meal curve compared to simply remaining seated the whole time. The effect tends to be especially relevant for people who are older, more sedentary, or already somewhat insulin resistant, where those post-meal peaks tend to run higher and last longer than they otherwise would. What makes this particularly practical is the sheer size of the dose required. These aren't full workouts at all, just small interruptions, a few minutes here and there, repeated consistently. It reframes exercise a little too. Movement isn't only about burning calories at some later point. It can be about actively guiding what happens in the hours right after you eat, exactly when your body is quietly deciding where all that incoming fuel is going to go. Stretching, it turns out, works through a slightly different mechanism than most people assume. It's easy to imagine stretching simply lengthens a muscle, the way you might slowly stretch a piece of taffy. In many cases, though, the bigger change actually happens in the nervous system rather than in the tissue itself. Stretching can teach your brain that a particular range of motion is genuinely safe, which can gradually raise the threshold at which a given stretch starts to feel threatening in the first place. That's part of why consistent stretching can noticeably increase flexibility, even when the physical length of the tissue itself has only changed modestly. It's partly a lesson in sensation, slow breathing, and gradual, patient pressure can reduce the protective reflex that otherwise tightens a muscle the moment it senses any risk. This is also why forcing a stretch too aggressively can backfire entirely. If the nervous system senses genuine danger, it may simply clamp down even harder in response. Stretching tends to work best when it's steady, specific, and aimed at movement you genuinely need in daily life. Hips for walking, shoulders for reaching overhead. Flexibility, seen this way, isn't only geometry. It's a kind of trust, quietly rebuilt between brain and body, one small session at a time. Balance follows a remarkably similar pattern. It's a genuine skill, and like any skill, it improves noticeably with practice. When you deliberately challenge your balance, your brain updates how it coordinates responses across the ankle, hip, and trunk, gradually learning to correct a wobble faster and faster over time. These corrections happen well before any conscious thought is involved, which is exactly why practice matters so much here. You're training a reflex, not simply giving yourself a mental lecture. Simple drills can be genuinely powerful. Standing on one leg while brushing your teeth, turning your head gently while walking, stepping carefully over a small obstacle. Practices like Tai Chi build exactly this kind of skill through controlled weight shifts and close attention to foot placement. Balance training also strengthens the smaller stabilizing muscles around your joints, helping them feel more reliable overall, which matters increasingly as reaction time and vision naturally shift with age. The underlying goal was never to become entirely fearless. It's to become recoverable. A stumble becomes far less likely to turn into a genuine fall once your body has quietly rehearsed the exact same small save 1,000 times before, in calm, unremarkable conditions. Even short bursts of more intense effort can reshape fitness in surprisingly little time. Interval training works largely because it asks your body to switch gears quickly. A brief burst near your own limit forces your heart, lungs, and muscles to deliver and use oxygen at a genuinely high rate. And the recovery period that follows teaches your system to clear byproducts and reset efficiently. Repeating that pattern can improve both aerobic capacity and overall efficiency, using considerably less total training time than a steady, moderate workout would require. It isn't automatically better for every single goal or every body, and pushed too aggressively, the intensity can be genuinely hard on both joints and motivation. The smarter version tends to be carefully scaled, brief bursts of faster walking uphill, short surges while cycling, a slightly quicker pace for a handful of laps while swimming. Many people find a simple ratio works well, something like 1 minute of real effort followed by 2 minutes of easy recovery, repeated a handful of times. What makes intervals genuinely interesting is how directly they turn fitness into an ongoing conversation with your own limits. You touch the edge, you ease back, and slowly, over the following weeks, that edge quietly moves further out. And underneath nearly all of this sits one of the most fundamental physiological changes exercise produces: how efficiently your own cells actually use oxygen. Building aerobic fitness isn't only about training your lungs or your heart in some general sense. You're genuinely upgrading the way your cells harvest energy at the cellular level. With regular aerobic activity, your muscles can increase their number of mitochondria, improve how effectively they use available oxygen, and rely less on the kind of emergency energy pathways that burn out quickly under strain. Your heart can begin pumping more blood with each individual beat, meaning it can deliver oxygen with noticeably less effort at the very same pace as before. Tiny blood vessels within your muscles can even grow denser over time, giving oxygen more doorways through which to enter working tissue. The payoff here isn't limited to athletic performance either. Stairs start to feel easier, carrying groceries feels less dramatic, and even your recovery after ordinary stress tends to improve, simply because the whole system has gotten better at returning smoothly to its own baseline. Aerobic fitness, in a very real sense, raises the efficiency rating of the machine you happen to live inside every single day. Let's turn now towards sleep itself, because so much of what we've just walked through depends, quietly, on how well the night before actually went. Sleep loss changes the chemistry of appetite before you've even made a single conscious choice about food. When sleep runs short, the body often raises signals that increase hunger, while simultaneously lowering the signals that would normally help you feel genuinely satisfied. The result isn't only feeling hungrier in some vague sense. It can be feeling noticeably less satisfied by an entirely normal portion. Sleep loss can also impair how well your body handles glucose, which can leave energy feeling unstable and trigger more frequent snacking simply for quick relief. Many people notice they drift specifically towards salty or sugary foods after a short night, then feel less real control around them than usual. This pattern can accumulate quietly, especially during unusually busy weeks when sleep keeps getting repeatedly shortened. The solution here was never really about harsh restraint. It's about recognizing the actual lever at play. Rest itself changes the underlying baseline. When you protect your sleep, appetite signals become noticeably more proportional again. Cravings soften, and it simply becomes easier to stop eating once you're genuinely, comfortably full. Even the light you happen to encounter first thing in the morning can shift your entire sleep schedule, cloudy day or not. Your eyes do far more than simply form pictures. Specialized, light-sensing cells send timing signals directly to your brain's own master clock. Morning light tells that clock, quite plainly, that this is daytime, and that the countdown toward tonight has officially begun. That single signal can move your whole sleep schedule earlier, and it can make it noticeably easier to feel genuinely sleepy at a consistent time each night. Even on a cloudy day, ordinary outdoor light is usually far brighter than typical indoor lighting, which is part of why stepping outside soon after waking can be so quietly powerful. The effect isn't only about raw brightness either. Timing matters enormously too. Morning light tends to advance your internal clock, while bright light late in the evening tends to delay it instead, which helps explain why screens at night can nudge your natural sleep timing later than you'd otherwise prefer. You might think of morning light as a kind of daily reset button. A short, regular dose each morning can quietly anchor your rhythms, improve daytime alertness, and make sleep itself feel considerably more predictable. Temperature plays its own quiet role as bedtime approaches, too. As you prepare for sleep, your body begins a subtle heat shift. Core temperature naturally starts to drop, while blood flow to your hands and feet often increases slightly, releasing warmth outward. That gentle cooling trend supports your transition into deeper sleep, the stage where the brain becomes genuinely harder to wake and the body focuses most heavily on repair. If you happen to feel too warm, sleep can fragment, simply because the body struggles to complete that natural temperature drop. Counterintuitively, a warm shower or bath before bed can actually help many people for exactly this reason. It warms the skin initially, then triggers a stronger release of heat afterward, leading to a smoother, more complete cooling curve overall. Breathable bedding, a cooler room, and avoiding a heavy meal right before sleep can all support this same process. This isn't only about comfort, either. Temperature functions as a genuine biological signal here. Your brain reads it as a direct cue for night, and when that cue comes through clearly, sleep can deepen, and the following day can feel noticeably steadier as a result. Your organs, it turns out, keep their own separate clocks too, not only the brain. The liver anticipates meal times and prepares its enzymes accordingly. Fat tissue changes how it stores and releases fuel depending on the hour of the day. Immune cells shift their activity across the day as well, which may be part of why certain symptoms tend to feel noticeably worse at night or early in the morning. These separate clocks are coordinated by shared signals like light exposure, sleep timing, and even when you happen to eat. When your daily schedule stays reasonably steady, these clocks stay aligned, and the whole body tends to run smoothly as a result. When your schedule swings unpredictably, though, these clocks can drift out of sync, almost like musicians quietly following different conductors at once. This is part of why shift work can be genuinely challenging on the body, and why eating very late at night can confuse metabolic timing, since the gut ends up receiving food right when other organs are already expecting rest instead. The genuinely hopeful part is that this alignment can improve again. Steady sleep, consistent meal timing, and regular daytime light exposure can all help bring the whole internal orchestra gently back into tempo. Naps carry their own particular value here too, especially for certain kinds of learning. A short nap isn't only rest in some passive sense, it can actually function as a genuine reset for memory. After practicing something new, whether a piano sequence, an unfamiliar language sound, or a tricky sports movement, the brain needs time to stabilize what you just learned, and brief bursts of brain activity that occurred during lighter sleep, called sleep spindles, are closely linked with exactly this kind of consolidation. Deeper, slow-wave sleep plays a role here too, helping file information away and freeing up capacity for whatever comes next. That's part of why some people wake from a nap feeling genuinely clearer, not just less tired than before. Length matters quite a bit. A brief nap can boost alertness without much grogginess afterward, while a longer nap can reach deeper stages and strengthen memory considerably more. Timing matters too, since naps taken too late in the day can quietly steal some of the pressure your body needs to fall asleep easily that same night. Used thoughtfully, though, a nap becomes a genuine tool, one capable of turning ordinary practice into real, lasting progress. Even dreaming itself may carry a quiet, practical purpose. Dreams can feel strange, and yet they may genuinely serve a useful function all the same. During certain sleep stages, The brain replays fragments of recent experience and emotion, then remixes them into entirely new scenes. This can resemble a kind of training simulator, letting you face fear, loss, or surprise without any real-world consequence attached. Researchers have linked dreaming, especially during rapid eye movement sleep, with the processing of emotional memories specifically. People often report that a difficult problem feels noticeably less sharp after a full night's sleep, even though nothing about the actual situation has changed at all. That softening may come directly from the brain, quietly revisiting the underlying feeling while the body itself stays completely safe in bed. When nightmares repeat instead, it can suggest the system has gotten stuck somewhere, as often happens with trauma-related sleep disturbance. And therapies that gently reshape a recurring nightmare script can genuinely help, which hints strongly that dreams were never meaningless noise to begin with. They may be part of how the brain quietly updates its own emotional predictions, night after night. In the dark, quiet theater of sleep, your mind may simply be rehearsing calm. Let's pause here for the tagline that's become a little ritual of its own on this channel. Because if any of this is helping your mind unwind tonight, and you'd like more of these slow drifts through the strange and the vast, you're welcome to stay a while longer or come back another night. One quiet mind at a time. That's really all this is for. Now, back into the dark and deeper into the body's own quiet architecture. Let's rest for a moment on digestion, because so much of what happens there runs almost entirely on its own, without ever needing your conscious attention. Deep within the walls of your digestive tract lives an entire network of neurons capable of coordinating movement without waiting for a single instruction from your brain. It senses stretch, monitors chemical signals, and directs your muscles to squeeze in carefully timed waves that push a meal steadily forward. If you've ever felt your stomach flip during a stressful moment, that's partly this very same system. It listens closely to emotion and hormone levels and changes its own rhythm in response. It can speed up, slow down, or tighten in ways that feel entirely, physically real. This gut network also talks back to the brain, using both nerves and chemical messengers, which helps explain why nausea can noticeably raise anxiety and why genuine calm can settle an unsettled stomach in turn. It isn't a second brain in quite the way that phrase sometimes gets used, but it is a remarkably independent control room all the same. Digestion is, in a very real sense, a form of choreography, and your gut conducts a great deal of it entirely on its own. Fiber plays a particularly important role in feeding that same system. Some foods reach your large intestines still largely intact, since your own enzymes simply can't break them down completely on their own. That's exactly where fiber becomes valuable. Resident microbes take over instead, fermenting it into short-chain fatty acids capable of fueling cells in the colon directly and helping maintain a genuinely strong intestinal lining. That matters enormously, because a stronger lining keeps irritation and unwanted particles from slipping unnecessarily into the bloodstream. Fiber also changes the physical environment of the gut more directly, holding water at bulk and supporting smoother, more regular movement overall. Different types of fiber feed different microbes too, which is why genuine variety tends to matter more than chasing any single miracle ingredient. Beans, oats, lentils, and a wide range of vegetables each offer something genuinely distinct. When people increase fiber intake quickly, gas can rise noticeably at first, simply because the resident microbes are actively adapting to the change. A slower, steadier increase gives that entire ecosystem time to properly reorganize itself. Fiber, seen this way, was never simply a supplement. It's an ongoing conversation with the living community already inside you. That same community can even manufacture certain nutrients directly. Your body naturally gets most nutrients from food, but some can also be crafted internally by the very microbes living quietly in your gut. Certain bacteria can synthesize vitamin K and several of the B vitamins, then share them within the surrounding intestinal environment. This doesn't mean diet can simply be ignored, since the amount and overall usefulness of these microbial vitamins vary considerably between individuals and depend heavily on gut health and whatever else happens to be going on in digestion at the time. Still, it's a genuinely striking idea. You aren't only eating vitamins each day. In a real sense, you're hosting a tiny, ongoing workshop capable of making some of them for you. This is part of why a long course of antibiotics can sometimes be followed by digestive upset or subtle shifts in nutritional status. The microbial community itself has been thinned out, and that internal workshop may run a little less smoothly for a while afterward. It also helps explain why genuinely diverse diets tend to support health in more ways than we can directly observe. Some benefits arrive indirectly, quietly carried on nothing more than microbial labor. Your stomach, meanwhile, protects itself from its own acid through an elegant bit of built-in engineering. It can hold acid strong enough to help break down food and destroy many microbes outright, and yet it doesn't normally digest itself in the process. That's because it maintains a protective barrier of mucus and bicarbonate, carefully buffering the acid right near the surface of the tissue itself. Beneath that layer, stomach lining cells are replaced remarkably quickly, almost like tiles swapped out well before any cracks have a real chance to become genuine leaks. When this protection gets disrupted, irritation and ulcers can follow. One common culprit is infection with a particular bacterium capable of weakening these defenses and inflaming the lining directly. Certain pain medications, especially frequent use of some anti-inflammatory drugs, can reduce these same protective factors in some people as well. The stomach's job here is genuinely harsh by nature, so it builds in real redundancy. It manufactures a dangerous substance, then carefully wraps itself in its own shield against it. Health here was never about eliminating acid altogether. It's about preserving the barrier that keeps that acid exactly where it belongs, working for you rather than against you. The pancreas manages a related balancing act of its own, using two opposing hormone teams. After you eat, sugar enters your bloodstream, and the pancreas behaves almost like a skilled referee, releasing insulin to help move that glucose into cells, especially in muscle and fat tissue, where it can either be used immediately or stored for later. Between meals, as glucose levels begin to dip, an entirely different signal rises instead, glucagon, which tells the liver to release some of its own stored glucose, keeping your brain properly supplied and your energy levels steadier overall. These two hormones work together as a pair, one lowering blood sugar and one raising it, so that your levels stay reliably within a genuinely usable range. When this particular balance breaks down, the consequences tend to unfold slowly, but seriously. This entire system was never only about dessert. It's fundamentally about survival, since too little glucose can meaningfully impair the brain, while too much can quietly damage blood vessels over time. The pancreas, in effect, is a quiet negotiator, adjusting its output patiently, hour after hour, for your entire life. Nearby, your gallbladder handles its own small, but genuinely elegant piece of the puzzle. Bile itself is produced in the liver, but it isn't always needed at full strength right away. The gallbladder stores and concentrates that bile, then releases a timed, concentrated squeeze whenever fat actually enters the small intestine. This release helps break fat down into tiny individual droplets, making it considerably easier for digestive enzymes to actually process. a little like adding soap to greasy water, letting the fat disperse so it can finally be handled properly. When the gallbladder has been removed, bile still reaches the intestine regardless, though it arrives more continuously and in smaller, steadier amounts rather than in distinct bursts. Many people adjust to this just fine, though some do notice a difference with especially fatty meals. Gallstones can form when certain components of bile harden over time, occasionally blocking flow and causing sharp pain after eating. The gallbladder itself is genuinely small, but its timing is remarkably elegant, proof that health often depends as much on delivery systems as it does on the raw ingredients themselves. The right substance, released at exactly the right moment, can change how an entire meal ends up being absorbed. Your small intestine solves an entirely different kind of problem, simple lack of space, through some genuinely elegant engineering of its own. If your intestine were nothing but a smooth, simple tube, you wouldn't be able to absorb nearly enough to actually thrive. Instead, the inner surface folds into ridges, then into countless tiny, finger-like structures called villi, and then again into even smaller microvilli, creating an enormous total surface area packed into a surprisingly compact space. Nutrients pass through that lining into your blood and lymphatic system, guided by specialized transporters that function almost like selective doors. Some carry sugars, others carry amino acids, and fats often take an entirely separate route through the lymphatic system instead. This is also part of why damage to this particular lining can matter so profoundly. In celiac disease, for instance, gluten can trigger an immune reaction capable of flattening these villi, reducing absorption and causing symptoms that reach far beyond the gut itself. Your small intestine was never simply a pipe. It's an interface, a living filter, quietly deciding, meal by meal, what actually becomes a part of you. Everything absorbed their heads, almost immediately, straight toward the liver. After nutrients are absorbed, much of the blood leaving your intestines travels first through a special route called the portal vein, giving the liver first look at everything you've just eaten, including sugars, fats, alcohol, medications, and any toxins that may have slipped through along the way. The liver can store glucose as glycogen, package fats for later use, and modify various chemicals so they become either safer to use or easier for the body to eliminate entirely. It also helps process bacterial fragments that occasionally cross over from the gut, reducing the chance that your immune system overreacts unnecessarily. This entire setup is genuinely smart. The gut represents the largest entry point for outside material anywhere in the body, so it makes sense that the body places a major processing plant directly downstream from it. It's also part of why heavy drinking can be so damaging over time, since alcohol arrives concentrated, and the liver has to process it repeatedly, batch after batch. You might picture the liver as customs at an especially busy port, stamping passports, confiscating anything genuinely dangerous, and carefully deciding exactly what gets released back out into the wider body. Remarkably, this same organ can rebuild itself, provided the damage doesn't continue indefinitely. After certain kinds of injury, the liver can actually increase its own rate of cell division and restore working tissue mass, sometimes astonishingly quickly. Surgeons can remove a genuinely large portion of a living donor's liver for transplant, and the remaining tissue will grow back until it once again meets the body's overall demands. That recovery isn't a simple rewind, either. The rebuilt structure is shaped carefully by blood flow, nutrition, and the specific chemical signals guiding repair at every step. Alcohol, certain viruses, and some toxins can interrupt this entire process by keeping the underlying damage active, which tends to push healing towards scar formation instead of genuine renewal. Once that ongoing injury pressure finally lifts, though, the liver's normal repair programs can reassert themselves once again. This capacity reveals something genuinely important about health more broadly. It isn't only about avoiding harm in the first place. It's also about giving the body the time and the conditions it needs to do the very thing it was already built to do all along. Let's rest here again for a moment. Let your breathing settle into its own quiet rhythm, the same steady, unhurried rhythm your gut has been keeping this entire time, long before you ever thought to notice it. Let's turn now toward the body's circulation and a handful of quiet organs that rarely ask for any real attention. Blood is easy to picture as a simple fluid moving quietly through the body. In truth, it behaves far more like an organ in constant motion. Red cells deliver oxygen for energy. White cells patrol continuously for threats. Platelets rush immediately to plug any leak. Plasma carries hormones that help coordinate appetite, stress, and growth throughout the entire body. Blood also moves heat directly. When you flush red and warmth, your vessels widen to shed excess heat through the skin, and when you turn pale and cold, they narrow instead, conserving warmth deep in your core. Even clotting itself is a carefully timed story, since it needs to seal real damage without ever blocking healthy flow elsewhere. Hydration changes overall blood volume, which affects exactly how hard your heart has to work. Iron status changes how well oxygen actually gets delivered, which can shift stamina and mental focus considerably. Blood, in effect, connects every organ in your body to every other organ. It's the body's own courier network. When it's healthy, messages arrive right on time. When it's genuinely strained, the whole system tends to feel it, one way or another. Tucked quietly under your ribs, the spleen works almost like a warehouse for parts of that same blood supply. It filters aging red cells out of circulation, checks the blood for certain microbes, and holds a genuine reserve of platelets on standby. Those stored platelets matter enormously, since they help form clots that stop bleeding when it counts. When the body faces sudden stress, contraction signals can push that stored reserve back into active circulation almost instantly. An emergency boost, essentially, like opening a reserve fuel tank exactly when it's needed most. The spleen also plays a genuine role in immune responses, helping present suspicious material to immune cells, which supports faster recognition of real threats down the line. Some people do live entirely without a spleen, following an injury or surgery, though they typically need extra protection against certain infections afterward, since that particular filtering role has been lost. This makes the spleen remarkably easy to overlook, right up until it's gone. Health, in general, is full of quiet helpers exactly like this, doing genuinely vital work in the background, and rarely, if ever, asking for any real attention in return. Your lymphatic system functions as a kind of second, parallel circulation, quietly clearing fluid and debris the whole time. Every day, fluid naturally leaks out of tiny blood vessels to bathe the surrounding tissue, and most of it needs a way back. That return trip is handled by lymph vessels, which collect excess fluid, proteins, and cellular waste, then carry it steadily back toward the bloodstream. Along the way, lymph nodes act almost like security checkpoints. Immune cells gather there to examine exactly what's being transported, helping the body respond quickly the moment a real pathogen appears. That's part of why lymph nodes can swell noticeably during an infection. They're simply busy at work. Lymph flow depends heavily on ordinary movement and breathing. Since the system, unlike the heart, lacks any strong central pump of its own, muscle contractions squeeze the lymph vessels directly and help move fluid along instead. That's one reason swelling can worsen with extended stillness. The lymph system, taken as a whole, handles drainage, transport, and immune surveillance all at once. It's a genuinely quiet engineering marvel. When it runs well, you never notice it at all. When it struggles, the whole body tends to feel noticeably heavier. Your thyroid, a small gland tucked into the neck, manages to nudge your entire metabolism using only tiny shifts in hormone output. It acts almost like a thermostat for how your body uses energy. Its hormones influence how quickly cells convert fuel into heat and useful work, which in turn affects heart rate, temperature tolerance, digestion speed, and even how alert you happen to feel on any given day. Even a fairly modest change here can ripple outward considerably. When output runs low, people often feel sluggish, colder than usual, and mentally foggy. When output runs high instead, the body can feel noticeably revved up, faster heartbeat, restlessness, and sometimes unintended weight loss despite otherwise normal eating. Thyroid hormones also support growth and brain development directly, which is exactly why thyroid health matters so profoundly during both pregnancy and early childhood. The thyroid never acts entirely alone, either. It listens closely to signals from the brain and relies on dietary iodine to actually build its own hormones in the first place. It's a genuine reminder that health can hinge on remarkably tiny molecules, released in remarkably tiny amounts. Small signals, in the right place, can steer enormous systems. Your kidneys, meanwhile, filter your entire blood supply continuously, all day long, then fine-tune precisely what gets returned to you. Every single minute, these two organs receive an outsized share of your total blood flow and begin a careful sorting process. Tiny internal filters let water and small molecules pass through into microscopic tubes, while larger proteins and blood cells stay safely behind. Then comes the real work. The kidneys decide exactly what to keep, what to release, and what needs adjusting. They reclaim needed water, return glucose to circulation when levels are already normal, and carefully balance electrolytes like sodium and potassium, both essential for proper nerve and muscle function. They also help manage overall acidity, which matters for countless enzyme reactions happening throughout the body. When you're sick, sweating, or simply eating differently than usual, your kidneys keep recalculating constantly to protect that underlying stability. You rarely feel their work directly, and yet you feel the results every single time you stand up without becoming dizzy, every time your heartbeat stays steady, and every time your body chemistry stays comfortably within its own narrow, safe range. Beyond simple filtering, your kidneys also function as genuine decision makers within the body's hormone system. When they sense reduced blood flow or unusually low sodium delivery, they release a hormone called renin, which sets off a cascade capable of tightening blood vessels and raising blood pressure. This particular system is genuinely useful during dehydration or significant blood loss, though it can become a real problem if it stays overactive for too long. The kidneys also release a hormone called erythropoietin, which tells bone marrow to produce more red blood cells whenever oxygen delivery runs low, creating a fairly direct line between kidney health and overall stamina. They help activate vitamin D into a usable, active form as well, which supports calcium balance and bone maintenance throughout the body. So a kidney issue can quietly echo outward into fatigue and even bone weakness, and not only into changes you might notice in urine. It's genuinely striking how a pair of fist-sized organs can influence pressure in your arteries, oxygen in your blood, and strength in your skeleton, all through signals you never consciously see happening. Urine itself functions almost like a daily report card from your kidneys, and color offers one of the simplest available clues. A pale, straw-like color often suggests plentiful fluid intake, while a deeper yellow can suggest your kidneys are actively conserving water instead. The story has a few twists, though certain foods, like beets, can shift that color dramatically on their own, and some supplements can turn urine strikingly bright yellow all by themselves. Even the very first urine of the morning tends to run darker, simply because you've gone many hours without drinking anything at all. What actually matters here is the overall pattern, not any single glance. If the color stays consistently very dark, or if you ever notice red, brown, or a cloudy appearance paired with pain, that's genuinely worth checking with a doctor. In ordinary daily life, though, this simple, easy check can help you notice you're running low on fluids well before thirst itself becomes loud and insistent. A small, quiet feedback tool that keeps you gently curious about your own body's chemistry. Your bladder, similarly, is a stretch sensor with a genuinely strong opinion of its own. As it fills, nerves send signals that steadily rise in intensity until your brain finally decides it's time. If you repeatedly rush to the bathroom at very small volumes, though, the system can actually learn a new normal. The threshold for urgency can gradually drop, and the sensation itself can start arriving earlier, feeling noticeably more insistent than it used to. This pattern can develop during periods of anxiety, after a urinary infection, or simply through habits that form around convenience rather than genuine need. Caffeine tends to increase this same urgency for many people, since it can irritate the bladder directly and increase overall urine production at the same time. The genuinely hopeful part is that this system can relearn its old patterns just as easily. Bladder training uses gradual, deliberate timing changes to rebuild confidence and slowly raise the volume at which urgency first appears. Pelvic floor muscles matter here too, since they help control release and signal genuine safety to the rest of the system. The bladder was never simply plumbing. It's an ongoing conversation between nerves, muscles, and learned expectation. Hydration reaches all the way into how your heart has to work, too, often faster than people expect. Water isn't only about simple thirst. It helps determine exactly how much fluid is actually circulating through your blood vessels at any given time. When you're dehydrated, blood volume can drop, and your heart may need to beat faster or work harder just to maintain adequate pressure, especially the moment you stand up or begin exercising. This can feel like lightheadedness, a suddenly racing pulse, or simply reduced endurance during ordinary activity. Hydration also influences how well you're able to cool yourself through sweating, since sweat itself draws directly from your body's existing water stores. In hot weather, this particular strain can build quite quickly. On the other hand, drinking far beyond your actual needs carries its own risk, particularly if it dilutes sodium levels in the blood too much. Most bodies do genuinely well with steady intake, guided naturally by thirst and adjusted for circumstances like heat, activity, or illness. Ordinary food contributes meaningful water too, especially fruit, soup, and vegetables. Hydration, in the end, is a moving target rather than a strict fixed number, one of the fastest, simplest levers available to change how your entire cardiovascular system feels, today, right now. Even mild dehydration can worsen a headache or make concentration noticeably harder for some people. The brain is genuinely sensitive to shifts in fluid balance. As dehydration begins, blood volume can dip slightly, and blood flow regulation can shift in ways that may contribute directly to headaches in people who are especially susceptible. You might also feel mentally slowed, with attention slipping more easily than usual. This matters quite a bit in perfectly ordinary situations: a long meeting, a travel day, a busy morning where water intake has simply been low. Dehydration can make ordinary fatigue feel considerably heavier too, which then makes staying focused even harder in turn. Many people mistake this particular feeling for low motivation, then reach straight for caffeine without ever addressing the more basic, underlying need. A simple glass of water can sometimes soften the problem within minutes, especially if the headache happens to be linked to heat or physical exertion. Headaches, of course, have many different causes, and hydration certainly isn't a cure for all of them. Still, it remains one of the easiest variables to test for yourself. Your body communicates largely through sensation, and sometimes a headache is really just a message about missing fluid, and not about missing willpower at all. And your arteries themselves respond quietly to your daily habits, either stiffening gradually over time or staying genuinely supple instead. Arteries were never simple, rigid pipes. They're living tissue that actively responds to whatever happens to be flowing through them. When the inner lining stays well supported, it releases signals that help vessels relax and widen properly, which improves blood flow and helps lower overall pressure. When that same lining is repeatedly stressed instead by factors like smoking, chronically high blood pressure, or persistently elevated blood sugar, vessels can become measurably less flexible over time, and that stiffness alone makes the heart work considerably harder with every single beat. The genuinely encouraging part is that this entire system can improve again. Regular aerobic activity supports healthier vessel function directly. Dietary patterns that lower sodium and emphasize potassium-rich foods can help favorable blood pressure trends develop over time. Even simple stress management can matter here, since repeated surges in pressure place real, cumulative strain on the vessel walls themselves. Health, seen this way, was never only about what you eat or how you happen to look. It's also about how supple your circulation manages to stay, which quietly shapes your energy, your brain function, and your long-term risk all at once. Let's rest for a while longer here. Let your own pulse settle into its natural, steady rhythm. Not something you need to control tonight, only something you can quietly notice, and then simply let continue on its own. Let's turn now toward the nervous system and the surprisingly intimate relationship between your brain, your heart, and the sensations you experience as pain. Even lying perfectly still, your brain continues spending a genuinely large share of your daily energy budget. It has to keep billions of individual cells electrically ready, maintain delicate chemical balances, and run a constant stream of background tasks like breathing regulation and temperature control. All of that quiet work costs real energy. For an organ that makes up only a small fraction of your total body weight, it can demand roughly a fifth of your entire resting fuel supply. That's part of why a severe drop in blood sugar can feel so genuinely dramatic. The brain depends heavily on a steady, reliable supply to function properly. It's also why the brain works so hard to guard its own energy through smart, efficient shortcuts. It predicts, it filters, it automates wherever it possibly can. When you finally learn a skill well enough that it feels effortless, you're often simply reducing how much active, conscious control the task actually requires. Focus feels tiring precisely because it's expensive, metabolically speaking. The brain was never lazy. It's an energy strategist, constantly deciding exactly what genuinely deserves power right now, in this particular moment. Your heart, meanwhile, does far more than simply respond to your feelings. It actively helps shape them in return. With every single beat, pressure sensors in your arteries send information upward to the brain, and the brain uses that steady stream of data to estimate safety, effort, and potential threat, moment by moment. When your heart rhythm becomes fast and jagged, the brain may interpret the body as braced for danger, even when absolutely nothing is actually wrong in the room around you. When the rhythm stays steadier instead, it becomes considerably easier for the brain to label whatever sensations arise as manageable. This is part of why slow, deliberate breathing can genuinely feel calming. It can smooth out the very pattern of signals your brain happens to be receiving in that moment. Over time, the natural flexibility of your heart rhythm, often called heart rate variability, has been linked with genuine resilience under stress. This was never about forcing yourself to feel calm through sheer effort. It's about how your body's own signals quietly guide the story your brain ends up telling. Emotion, in a real sense, is partly a conversation, and the heart gets a surprisingly strong speaking role in it. Much of that conversation travels along a single, remarkable pathway called the vagus nerve. Picture a long cable running from the brain all the way down to the belly, branching off along the way to touch the heart and lungs as well. That cable carries messages in both directions at once. It can slow the heart following a stressful moment, influence your breathing pattern directly, and affect how your gut moves food forward through the digestive tract. It also carries sensory reports back upward, including stretch, nausea, and even subtle inflammatory signals from deep within the body. That means a genuinely troubled stomach really can darken your mood, and a calmer breathing pattern really can ease digestive discomfort in return. The vagus nerve is even involved in a kind of built-in braking system for inflammation itself, sometimes described as an inflammatory reflex. This is part of why practices emphasizing long exhalations, gentle humming, or relaxed swallowing can feel surprisingly regulating for some people. They aren't magic tricks of any kind. They're simply small, deliberate ways of nudging one of the body's major communication highways, one signal at a time. Pain itself turns out to be, at its core, an experience the brain constructs, rather than a direct, one-to-one reading of physical damage. Pain is genuinely real, and yet it was never a simple alarm wire running straight from tissue to mind. It's really the brain's best guess about danger, built carefully from nerve signals, memory, attention, and surrounding context all at once. That's exactly why you can bump your shin and feel absolutely nothing at first, only to suddenly hurt the moment you happen to look down and actually see it. The brain updates its own prediction the instant it believes a situation is genuinely serious. It's also why phantom limb pain can exist even after an arm or a leg is entirely gone. The brain still holds an internal map of that limb, and the map itself can occasionally misfire. This entire system is fundamentally protective by design, though it can, at times, become overprotective instead. Long after an injury has actually healed, nerves and brain circuits can sometimes stay sensitized, keeping pain signals loud well past the point where they're still genuinely useful. Understanding this doesn't dismiss anyone's suffering in the slightest. If anything, it opens real doors. Treatment can involve movement, reassurance, and careful retraining, and not only an ongoing chase after tissue damage that may no longer even be there. The underlying goal becomes safety learning, rather than simply silencing a signal outright. Chronic pain, over time, can genuinely reshape attention itself, making ordinary sensations feel considerably louder than they otherwise would. When pain persists for long enough, the nervous system can begin treating it as a constant, standing priority. Attention gets pulled steadily toward the body, scanning repeatedly for any change, any hint of danger. This can make even small, ordinary sensations feel genuinely alarming, which increases stress in turn, which can then amplify the original pain even further in a fairly tight feedback loop. Over time, the brain can become quite skilled at producing pain, in much the same way it becomes skilled at any other repeated task. That doesn't mean the pain itself is imagined in any sense. It means the underlying system has simply learned a persistent pattern. Chronic pain can also narrow someone's life considerably. People understandably avoid movement. Sleep often becomes lighter, and social plans tend to shrink, all of which can worsen both mood and overall sensitivity in turn. Modern approaches to pain science increasingly focus on gently retraining this entire system instead. Gradual, carefully graded movement can rebuild real confidence over time. Safer sleep routines can genuinely reduce overall sensitivity. Cognitive and behavioral approaches can shift how the brain labels a given signal in the first place. Medication still has a role too, especially during flares. The underlying goal was never to win some single dramatic battle in a single day. It's to gently change the loop itself, so the brain gradually stops treating every ordinary sensation as an active threat. Migraines, similarly, involve entire brain networks rather than simple, isolated blood vessels alone. A migraine is genuinely more than an unusually bad headache. It can involve waves of altered brain activity, real shifts in sensory processing, and meaningful changes in how the body's pain pathways are regulated overall. Some people experience an aura beforehand, which can include shimmering lights, temporary blind patches, or a distinct tingling sensation, arriving well before the pain phase itself even begins. Many people become noticeably sensitive to light, sound, or certain smells during an episode, almost as though the brain's own volume knobs have all been turned up too high at once. Triggers vary enormously from person to person. Irregular sleep for one person, missed meals, dehydration, bright glare, hormonal shifts, or particular foods for someone else entirely. That sheer variety fits well with the idea of a broader network condition, since so many different inputs can each push the same underlying system toward its own particular tipping point. Treatments vary quite a bit too. Some aim to stop an individual attack early. Others focus on reducing overall frequency, and lifestyle patterns often matter considerably alongside any medication involved. Migraines can genuinely disrupt work and family life, and they're frequently misunderstood by people who haven't experienced one directly. Understanding them as a genuine brain state, rather than simply a headache, helps explain why they can affect vision, mood, and overall energy, and not only pain in isolation. Let's rest for a moment here. Let your own breathing settle further, slow, and complete. The exhale a little longer than the inhale, the way your body already knows how to signal safety to itself. Let's turn now toward the senses, because so much of how we experience the world runs through systems most of us rarely think about directly. Your skin functions as a genuine immune organ, rather than simply a passive, protective covering. It's a living border, actively deciding what gets in, what stays out, and exactly how loudly to react when something crosses the line. It manufactures antimicrobial compounds, recruits immune cells when needed, and alerts the rest of the body the moment something breaches the surface. When you get a small cut, the very first response is fast and entirely local. Cells release signals that call for clotting and cleanup, then carefully coordinate the repair process from there. Skin also hosts its own community of resident microbes, which can help crowd out potential troublemakers before they ever get a real foothold. When that barrier dries out, cracks, or becomes inflamed instead, it becomes considerably easier for irritants and pathogens to slip through unnoticed. That's part of why a condition like eczema can feel like considerably more than a simple rash. It can genuinely represent a barrier failure with real immune consequences attached. Caring for skin, seen this way, is surprisingly medical in nature. Hydration, gentle cleansing, and protection from harsh sun exposure were never merely cosmetic extras. They actively support one of the largest immune front lines your body has. Even saliva turns out to be doing considerably more work than most people ever give it credit for. before food ever reaches your stomach. Your mouth has already started the underlying chemistry. Saliva contains enzymes that begin breaking down starches almost immediately, which is part of why a plain cracker can taste faintly sweet after sitting in your mouth for just a moment. At the same time, saliva washes away food particles and helps balance the acids that would otherwise attack your enamel directly. It carries calcium and phosphate capable of rehardening microscopic weak spots on your teeth after a meal, a quiet repair cycle that repeats itself patiently all day long. When saliva flow drops for any reason, cavities and mouth irritation become considerably more likely. This can happen with dehydration, mouth breathing during sleep, certain medications, or ordinary stress. Chewing sugar-free gum can help stimulate saliva production, and so can simply sipping water steadily throughout the day. Your mouth was never only an entry point for food. It's a busy, genuinely protective environment, complete with its own built-in maintenance system running quietly the entire time. Good oral health starts, in large part, with simply respecting that invisible, ongoing rinse and rebuild cycle. Blinking, similarly, looks entirely simple on the surface, and yet it's a genuine precision maintenance cycle, running continuously all day long. Each blink spreads a fresh layer of tear film across the cornea, smoothing the optical surface so light can enter cleanly and consistently. It also washes away dust, pollen, and tiny irritants well before they have a chance to scratch the surface. Tears themselves carry oils that slow evaporation, water that keeps the surface properly hydrated, and proteins that help control microbes directly. When you stare at a screen for long stretches, your blink rate often drops noticeably, and the tear film itself can begin to break up as a result, which can leave your eyes feeling gritty, tired, or oddly watery as your body tries to compensate. Blinking plays a genuine role in the brain too, creating brief visual breaks that help the mind stitch perception together into one smooth, continuous scene. You don't notice this flicker at all, because your brain simply edits it out entirely. Every single blink is a small reset, an invisible wipe across the lens, quietly keeping your entire visual world clear. Hearing loss, when it happens, can genuinely increase cognitive load, making ordinary thinking feel noticeably harder than it used to. When hearing becomes less sharp, the brain often works considerably harder to fill in whatever sound is missing. Instead of receiving clean, complete speech, it receives scattered fragments instead, and it has to actively predict what was actually said using context and memory alone. That constant guessing can genuinely drain mental energy, especially in noisy environments like a busy restaurant or a crowded street. Many people describe this specifically as fatigue, rather than as any kind of hearing trouble at all. They feel worn out after an ordinary conversation, and they may gradually withdraw socially simply because listening itself starts to feel like real work. Over time, that particular strain can crowd out attention needed for other tasks entirely. It can shift mood too, since effort and frustration tend to rise together. Hearing aids and other assistive devices can genuinely reduce this load by delivering clearer input from the start, which gives the brain some real relief. Protecting your hearing matters here too, since loud sound damage tends to accumulate steadily over time. Hearing was never only about volume. It's about mental bandwidth. When sound becomes clearer, thinking itself can genuinely feel lighter. Smell links unusually strongly to memory, and it can shift your appetite remarkably fast. Smell is wired into the brain in a way that makes it feel deeply personal. Odor signals travel to regions involved in emotion and memory, using noticeably fewer relay steps than most of your other senses require. That's exactly why a single, specific scent can bring back a childhood kitchen, a hospital corridor, or a particular season, with startling speed and clarity. Smell also shapes appetite well before you ever take a single bite. The aroma of baking bread can trigger saliva and genuine anticipation almost instantly, while the smell of spoiled food can shut appetite down completely, just as fast. In ordinary modern life, smell also plays a genuine role in hazard detection. Smoke, a gas leak, spoiled dairy are all frequently noticed through scent well before anything else gives them away. When your sense of smell is reduced for any reason, people often end up adding more salt or sugar simply to chase some sense of flavor, and they may miss important early warning cues in their environment as a result. Smell was never a minor sense at all. It's a genuine shortcut straight to memory, and a surprisingly fast lever on both desire and safety. Taste, in turn, is really part smell, which explains why an ordinary cold can dull flavors so dramatically. What you call taste is really more of a duet between two separate senses. Your tongue detects only a handful of basic signals: sweet, salty, sour, bitter, and savory. Much of what we actually experience as flavor comes instead from aromas rising up from the mouth into the nasal passages while you chew. When a cold blocks those same passages, your tongue keeps working exactly as before, but the aroma side of the experience goes quiet, and food can end up feeling strangely flat, even if it's been seasoned perfectly well. This also explains why warm food often tastes noticeably better when you're sick. Heat releases more aroma molecules overall, making it easier for whatever airflow you still have available to carry them upward properly. It's also part of why texture becomes considerably more important when smell is reduced. Crunch, creaminess, and temperature can all provide genuine interest when flavor itself starts to fade. Taste was never only located on the tongue. It lives in the entire route from mouth to nose together. And when that route stays clear, the brain builds an impressively rich flavor picture from nothing more than a series of tiny chemical hints. Balance, meanwhile, is really a group project involving several senses working closely together at once. In your inner ear, fluid-filled canals detect head movement directly, while tiny specialized organs sense both tilt and acceleration. Your eyes provide a steady visual reference for exactly where the surrounding world happens to be. Meanwhile, sensors embedded in your muscles and joints report where your limbs are actually positioned, even with your eyes fully closed. The brain blends all of these separate streams together to keep you from falling, updating its running calculation many times every single second. When any one of these sources becomes disturbed, the whole system can genuinely wobble. A dark room removes your usual visual anchors entirely. An inner ear infection can scramble motion signals directly, and weak ankle strength can reduce the overall quality of feedback coming up from the ground. That's exactly why balance can genuinely improve with deliberate practice. The brain learns, over time, to weigh whichever signals are most reliable, while gradually ignoring the noisier ones instead. Balance was never a single fixed skill you either simply have or simply lack. It's a constantly updated, ongoing calculation, and it absolutely can be trained. Motion sickness, closely related, turns out to be a genuine sensory mismatch, rather than any kind of weak stomach at all. It usually begins in the brain, and not really in the belly itself. If your eyes report that you're perfectly still, while your inner ear reports that you're actually moving, the brain faces a genuine conflict between the two signals. A common, everyday example is reading in a moving car. Your inner ear senses every turn and stop clearly, while the page in front of you stays perfectly stable, and your brain struggles to reconcile those two very different messages. The result can be nausea, sweating, dizziness, and a heavy, distinctly unpleasant fatigue. One evolutionary theory offers a genuinely interesting explanation here. In nature, this exact kind of sensory mismatch could have suggested poisoning, so nausea may have originally developed as a protective response of sorts. Practical solutions tend to work by directly reducing that underlying mismatch. Looking toward the horizon gives your eyes motion cues that finally match what your inner ear is already sensing. Sitting in the front seat of a car can genuinely help for the same reason. Fresh air and steady, deliberate breathing can reduce the intensity of symptoms considerably. Motion sickness was never a character flaw of any kind. It's simply an overactive conflict detector, occasionally misfiring under exactly the wrong circumstances. Even your visual blind spot reveals something genuinely fascinating about how perception actually works. Each of your eyes has a small blind spot, exactly where the optic nerve exits the retina, and there are simply no light-sensing cells present at that particular point. And yet you never actually see a hole anywhere in the world around you. Your brain quietly fills that gap using the surrounding pattern, color, and expectation instead. A small, everyday example of how perception is genuinely constructed rather than simply recorded like a photograph. The brain smooths over other brief interruptions too. When your eyes make quick movements called saccades, vision briefly suppresses itself entirely, and the brain quietly edits that moment so the surrounding world continues to feel stable and seamless throughout. This kind of editing is usually genuinely helpful. It does mean, though, that your everyday experience is partly a very educated guess. That matters for health more broadly too, since attention and stress can meaningfully change perception itself. When you're anxious, the brain can prioritize threat-related cues, filling in any remaining uncertainty with danger rather than safety. The same underlying machinery that quietly hides a blind spot can also, in the wrong circumstances, amplify ordinary worry. Understanding this can actually feel comforting in its own way. Your mind was never simply a camera, recording the world exactly as it is. It's a storyteller quietly stitching reality into one smooth, continuous, coherent scene. Let's turn now toward temperature itself, because keeping your body at the right heat turns out to be a remarkably active, ongoing project. Sweat cools you specifically through evaporation and not simply through the act of dripping on its own. Sweat works best exactly when it disappears. When liquid sitting on your skin turns into vapor, it steals heat directly from your body in the process. And that theft is where the actual cooling comes from. In dry air, evaporation happens quickly, so even a fairly light sweat can cool you quite effectively. In humid air, though, evaporation slows considerably, since the surrounding air is already saturated with water, which means sweat can simply drip without offering much relief at all. That's part of why humid heat tends to feel so much heavier and genuinely more dangerous than dry heat of the same temperature. Air movement matters here too. A breeze, a fan, or simply your own walking speed can carry moist air away from your skin and meaningfully improve overall cooling. Clothing can help or hinder this process too, depending on whether it allows for proper airflow and evaporation. This entire system is part of why heat illness can sneak up on someone so easily. You might genuinely be sweating heavily and still overheating if the surrounding environment is actively blocking evaporation from happening. Your body is essentially trying to run its own internal air conditioner, and the outside world largely determines how well that system actually gets to work. Given repeated exposure, the body can genuinely adapt to a hot climate over time, easing much of that underlying strain. If you spend several consecutive days in hot conditions, your body can begin adapting in ways that make the heat feel noticeably less punishing than it did at first. One of the earliest changes is an increase in plasma volume, the liquid portion of your blood. More plasma helps the heart move blood efficiently toward the skin for cooling, all while still properly supporting your muscles and other organs at the same time. Sweating itself can begin earlier too, and become genuinely more effective, partly through changes in exactly how salty that sweat actually is. Heart rate during a given workload often drops as the whole system becomes more efficient overall. None of this happens instantly. It builds gradually over several days, then continues deepening over a couple of weeks with consistent exposure, and it can fade again once you return to a cooler environment. This kind of heat acclimation is not the same thing as genuine immunity, either. Extreme heat can still be genuinely dangerous, especially combined with dehydration, illness, or particularly heavy exertion. Still, it's genuinely impressive that your body can tune itself to a given climate at all, adjusting blood volume, sweat, and cardiovascular control almost like a living thermostat quietly learning an entirely new setting. Cold prompts an entirely different, faster emergency response instead. When you get cold, your body has a genuinely fast backup plan ready to go. It tells your muscles to contract in small, rapid bursts, generating heat as a natural byproduct of that activity. You aren't consciously choosing to move at all, and yet real energy is being burned specifically to defend your core temperature. Shivering can actually start before you even feel truly chilled, since the brain responds directly to skin temperature and works to predict risk in advance. It can also stop quite suddenly the moment you warm back up, since the whole process is tightly controlled by the brain throughout. This process is genuinely effective, though it's also fairly inefficient by nature. It burns through fuel quickly and can leave you feeling exhausted if it continues for too long. That's part of why cold exposure can be surprisingly tiring in its own right. Shivering also competes directly with fine motor control, which is exactly why cold hands so often fumble with something as simple as keys or buttons. In genuinely severe cold, shivering can eventually fade as energy stores drop and body temperature continues falling, which is actually a dangerous warning sign in its own right. Shivering, in the end, is your body's backup heater, loud, costly, and specifically designed for short-term survival rather than long-term comfort. Not all body fat exists purely for storage, either. A particular kind, called brown fat, is densely packed with mitochondria, the tiny power plants inside individual cells, and it's specifically wired to generate real heat on purpose. When activated by cold, it can burn fatty acids and glucose directly to warm the body, without any of the shaking effort shivering normally requires. Babies carry considerably more of this tissue, which helps them stay warm before they're able to regulate their own temperature effectively on their own. Adults can still carry some brown fat too, typically around the neck and upper chest, though the actual amount varies quite widely between individuals. Researchers study this tissue closely, since it changes how the body uses energy and handles fuel after a meal. Cold exposure can increase its activity to some degree, though the real-world effects on overall body weight remain genuinely complex, and are certainly not any kind of simple hack. Still, as a concept alone, it's genuinely remarkable. Your body contains tissue whose entire job is to deliberately waste energy, purely to protect your core temperature. It's a little like carrying a small furnace tucked quietly under the skin, simply waiting for winter's first cue to arrive. Even fever, uncomfortable as it feels, represents a coordinated, deliberate strategy rather than simple malfunction. A fever isn't only heat in some raw sense. It's a coordinated shift in your body's internal set point, driven directly by immune signals that tell the brain to deliberately raise your core temperature. Many pathogens reproduce best within a fairly narrow temperature range, so a higher body temperature can genuinely make that environment considerably less comfortable for them to thrive in. At the same time, certain immune processes actually work more efficiently when warm, including the movement of immune cells and some specific aspects of cellular signaling. That's the potential benefit side of the equation. The cost, though, is real too. Fever increases your overall metabolic demand, which can feel like genuine exhaustion and body aches. And it also increases fluid loss through breathing, and sometimes through sweating as well. In most otherwise healthy adults, a moderate fever is simply part of a normal, functioning defense response. Still, a genuinely high or prolonged fever can be dangerous, especially in young children, older adults, or anyone managing a chronic illness. Treating a fever is often really about comfort and safety more than anything else, rather than purely stopping some kind of enemy tactic. Fever, in a sense, is the body deliberately choosing a hotter battleground and simply paying for that choice with fuel and rest. Inflammation, more broadly, functions as protective, right up until it becomes chronic and misdirected instead. Inflammation is really the body's own emergency lighting system. It widens blood vessels, brings immune cells directly to the scene, and helps clear away damage following an injury or infection. In the short term, it's a genuinely powerful repair strategy. The trouble tends to begin only when that particular signal doesn't fully shut off, or when it ends up targeting the wrong thing entirely. Chronic inflammation can quietly injure blood vessels over time, alter your body's insulin response, and place ongoing strain on tissue across years, not days. It can be driven by persistent infection, autoimmune conditions, long-term stress, smoking, poor sleep, or excess visceral fat, which releases its own inflammatory signals continuously. The underlying goal here was never to erase inflammation entirely, since you genuinely need it. The real goal is balance and eventual resolution, supporting that natural off switch through sleep, movement, nutrient-dense food, and appropriate medical treatment whenever it's genuinely needed. You might think of inflammation a little like a fire alarm. You genuinely want it to ring the moment there's real smoke. You simply don't want it blaring all night long, purely because its own battery happens to be failing. Let's slow all the way down now and gather part of the picture we've built together tonight before we drift into the last part of the journey. Let's turn gently toward the mind and the many quiet ways it shapes health from the inside. Relaxation itself can genuinely lower muscle tension, which can, in turn, ease certain ongoing pain cycles. Tension is really a form of holding, and the body can learn it as a habit over time. Jaw clenching, raised shoulders, shallow breathing, and a generally guarded posture can all keep muscles partially contracted for hours at a stretch. That constant load can reduce local blood flow, increase irritation, and trigger headaches or neck pain in some people as a direct result. Relaxation techniques work, in large part, by changing that underlying baseline. Slow, deliberate exhalations can cue the nervous system to gently downshift. Progressive muscle relaxation specifically teaches you to notice tension as it builds, then deliberately release it on purpose. Warmth can help too, both by improving local circulation and by signaling genuine safety directly to the brain. Even brief breaks in posture can matter here. Simply standing up, rolling your shoulders, or consciously unclenching your tongue from the roof of your mouth. This was never about pretending pain is purely mental. It's about removing one genuine contributor that so often rides along quietly with stress and fatigue. When tension finally drops, pain signals themselves can become noticeably less intense, and the body finally gets some real room to recover. Stress hormones, meanwhile, can genuinely change how quickly a wound closes and heals. When the body senses a real threat, it releases hormones that are genuinely useful in a true emergency, yet costly if they stay elevated for too long. Cortisol and related stress signals can shift the immune response and slow down the earliest steps of tissue repair. In careful studies, people under heavy, ongoing stress have shown measurably slower healing of small, controlled skin wounds compared with less stressed participants. The underlying difference here isn't magic at all. It's simple resource allocation. The body ends up prioritizing survival readiness over long-term rebuilding whenever it senses genuine, sustained threat. Stress can also disrupt sleep directly, and sleep happens to be exactly when repair signals naturally rise the most, a genuine double hit. None of this means stress dooms healing entirely, of course. It simply means recovery tends to improve considerably once the body receives clearer signals of genuine safety instead. Supportive relationships, time spent outdoors, calming breathing, and steady nutrition can all genuinely help here. Wound healing turns out to be one of the clearest places where mind and body visibly meet, leaving fingerprints you can actually measure afterward. The placebo effect offers one of the more striking examples of this same connection, capable of measurably changing pain, nausea, and even tremor. Expectation itself is never only a passing thought. It can function as a genuine biological instruction. When someone genuinely believes a treatment will help, the brain can release its own natural pain-dampening chemicals and change how signals are processed along the spinal cord and cortex in ways that can genuinely alter real symptoms, including nausea, itch, and fatigue. In Parkinson's disease research specifically, placebo responses have even been linked to measurable dopamine release, briefly improving movement in some patients. This effect never means the original symptoms were somehow fake. It means the brain carries built-in controls capable of turning volume up or down, based heavily on context, trust, and prediction. It's also exactly why the opposite effect exists too. If people expect genuine harm, symptoms can measurably worsen, even from a completely inert pill. Medicine takes this seriously for good reason. Clinical trials specifically use placebos to separate raw chemistry from simple expectation. Your brain, in the end, is part of every treatment you ever receive, whether that treatment happens to be a drug, a ritual, or simply a reassuring voice speaking calmly nearby. Much of your body's regulation, more broadly, turns out to be proactive rather than purely reactive. The brain is constantly guessing what you're likely to need next, then adjusting circulation and breathing well in advance of the actual need. Stand up, and your heart rate rises before you'd ever faint, precisely because pressure sensors and prediction circuits coordinate a genuinely quick response together. Start to run, and your breathing deepens immediately, because the brain already expects carbon dioxide levels to climb shortly. Even simple anticipation can shift this entire system. Thinking ahead about a stressful conversation can change your heart rhythm well before a single word has actually been spoken. This is part of a broader strategy sometimes called allostasis, which essentially means staying stable through ongoing change. The benefit here is speed. The risk is overshoot. If the brain predicts danger too often, the body ends up living in a noticeably higher gear than it genuinely needs. Practices like slow exhalation, paced walking, and steady daily routines can gently retrain those underlying predictions over time. Health, seen this way, is partly about helping your own brain feel safe enough to finally stop bracing quite so hard. Mindfulness practice appears to work by changing exactly how the brain predicts and labels ordinary sensations in the first place. Your brain is always predicting what a given sensation actually means. A flutter in your chest might be excitement, or it might be read as a genuine threat. A tight stomach might be simple hunger, or it might be interpreted as worry instead. Mindfulness practice trains you to notice sensations earlier and to label them with considerably more precision and less automatic panic. Instead of instantly escalating into a full story, you learn to stay with the raw data itself: warmth, pressure, simple movement. This can meaningfully reduce secondary stress, which so often adds real fuel to whatever the original sensation happened to be. Brain imaging studies suggest mindfulness can genuinely alter activity in networks linked with rumination and self-referential thinking, while simultaneously strengthening the brain's attention and control systems. This doesn't mean the mind goes entirely blank, either. It means you gradually gain a little more space between a sensation and your reaction to it. This can genuinely change habit loops too, since so many habits begin with an uncomfortable feeling that seems to beg for quick relief. Mindfulness was never really about staying calm every single moment. It's about becoming considerably more accurate. When you can name an experience clearly, the body often quietly stops shouting quite so hard just to be heard. Social connection, remarkably, predicts overall health outcomes about as strongly as some of the more familiar physical risk factors we typically worry about. A genuinely supportive social life isn't only pleasant in some abstract sense. It can meaningfully shape how long and how well people actually tend to live. Large studies have consistently linked stronger relationships with a lower risk of early death, with effects fairly comparable to several well-known health factors. Connection changes the body in several distinct ways at once. It can buffer the body's stress response directly, which helps keep blood pressure and inflammatory signaling from staying persistently elevated. It can also change behavior more broadly, since people often eat, move, and sleep quite differently when they genuinely feel supported by those around them. Even small interactions can matter here. Simply being greeted by name, or knowing there's someone who would genuinely notice if you disappeared for a day. Connection affects recovery too. People tend to seek care earlier, finish treatment more reliably, and keep appointments more consistently when they don't feel entirely alone in the process. Health is so often framed as a purely personal project, and yet the body, quite clearly, is deeply social. It listens to belonging almost the same way it listens to food, and it responds accordingly every single day. Loneliness, on the other hand, is linked to genuinely higher inflammation, even in the complete absence of any actual illness. When people feel isolated, studies have found measurable shifts in immune activity that closely resemble a body actively preparing for real threat, with higher inflammatory signaling sustained over time. This response may have been genuinely adaptive in a harsher, more physically dangerous environment. Since isolation there could very plausibly have meant greater physical danger. In modern life, though, it can settle into more of a slow, quiet, background strain instead. Inflammation is genuinely useful for fighting infection and repairing damage. It becomes harmful, though, when it stays elevated without any clear ongoing purpose. Loneliness can also disturb sleep directly and increase overall stress reactivity, adding still more fuel to the same underlying fire. Chronic loneliness specifically can make the nervous system stay slightly more alert at night, almost as though it expects the surrounding world to be less protected than it actually is, which can make sleep noticeably lighter and more fragmented, filled with small awakenings that are easy to forget by morning. The genuinely hopeful part here is that connection was never only about having a large number of friends. It can simply be about feeling seen and feeling genuinely supported. Volunteering, a regular class, or even small, consistent interactions repeated over time can all meaningfully help. Health includes the social world too, because your body listens closely to belonging in almost exactly the same way it listens to food. Even laughter turns out to genuinely shift stress hormones and briefly change how pain itself gets perceived. Laughter is really a whole body event. Breathing changes, facial muscles contract, and heart rate typically rises before settling back down again shortly after. In the brain, laughter can activate genuine reward pathways and release the body's own natural pain-dampening chemicals, which is part of why a truly hard laugh can make discomfort feel noticeably farther away for a while afterward. It can also reduce stress hormone levels in certain situations, especially when the laughter comes paired with real social bonding, rather than simple forced cheerfulness. Even anticipation alone can matter here. Genuinely looking forward to something funny can measurably change tension well before the actual punchline ever arrives. None of this means laughter cures disease outright, and it's certainly not something you can simply command on demand. Still, it represents a genuinely powerful shift in state. It can interrupt rumination, relax habitual muscle-holding patterns, and make real connection with others considerably easier in the moment. Humor changes attention too. While you're laughing, your mind isn't actively rehearsing worst-case scenarios. For a brief, genuine moment, the body is living inside an entirely different chemistry, and that chemistry can feel, quite simply, like real relief. Grief, understandably, can affect immunity too, making infections genuinely more likely for a period of time afterward. Grief is a real stressor that touches nearly every system in the body at once. During bereavement, many people sleep poorly, eat irregularly, and move considerably less than usual, and those changes alone can meaningfully weaken the body's defenses on their own. On top of that, grief itself can intensify overall stress signaling, which can shift immune function in genuinely measurable ways. Research has linked bereavement specifically with a higher risk of illness in the months immediately following a major loss. The body here isn't failing in any sense. It's simply allocating its limited resources toward a prolonged crisis state, which can leave meaningfully fewer resources available for fighting off ordinary pathogens in the meantime. Grief can increase inflammation too, which may worsen existing health conditions someone happens to already be managing. This is one genuine reason practical support matters so profoundly after a loss. Meals brought over, a walk with a friend, help with paperwork. These were never simply small kindnesses. They function as real health protection. Grief was never something to simply fix quickly. It's something to be carried, and the body, quite literally, carries it too. Being genuinely cared for during grief can meaningfully reduce the underlying biological cost of carrying it. Trauma, in its own way, can leave a genuine imprint on the body, subtly altering how the entire threat detection system operates afterward. After trauma, the body can effectively learn that danger might arrive without warning. The specific brain regions responsible for detecting threat can become considerably more sensitive, and stress responses can begin triggering faster, even inside settings that are genuinely, completely safe. This can show up as noticeable jumpiness, a racing heart, real muscle tension, and sleep disrupted by nightmares or sudden, unexplained awakenings. The body may also start avoiding sensations that resemble the original trauma in some way, certain smells, particular tones of voice, or simply crowded spaces. None of these reactions represent weakness in any sense. They're survival learning that has simply been turned up considerably too high. Over time, though, this same system genuinely can be retrained. Trauma-focused therapies help the brain refile a difficult memory as something firmly belonging to the past rather than the present. Breath work, movement, and grounding skills can all help the nervous system gradually learn safer patterns again. Supportive relationships matter enormously here too, since trust itself slowly teaches the body that connection isn't automatically a threat. Trauma can genuinely leave a physical signature behind, and yet the body, quite remarkably, remains changeable throughout. That imprint really can fade once safety becomes consistent enough, and once the nervous system is given enough new, different experiences to gently learn from instead. Habit itself, meanwhile, tends to rely far more on cues and rewards than on raw willpower alone. A habit is really more of a shortcut than a fresh choice made entirely from scratch each time. The brain links a particular cue to an action, and that action to a reward, and through simple repetition, the whole sequence eventually becomes largely automatic. The cue itself might be a particular time of day, a stress response, simple boredom, or walking past a familiar shelf. The reward might be comfort, stimulation, genuine relief, or just a small sense of completion. Once that loop has fully formed, the brain can actually start the behavior before you've consciously decided anything at all, which is exactly why habits can feel like they're running entirely on rails of their own. Changing a habit tends to work considerably better when you deliberately keep the original cue in place, while changing only the response, all while still delivering some genuine reward along the way. The cue of afternoon fatigue, for instance, could lead to a short walk instead of idle scrolling, with the reward becoming real alertness and a genuine mental reset instead. Environment matters here too. When a particular cue stays visible and genuinely convenient, that loop only strengthens further over time. Habit change, seen this way, becomes considerably less about raw moral strength and considerably more about simply redesigning the underlying cues and rewards involved. Willpower itself, it turns out, genuinely varies with sleep, stress, and blood sugar stability, rather than functioning as some kind of fixed personality trait. Self-control isn't a permanent character quality at all. It's a brain function that depends heavily on available resources. When you're sleep-deprived, the prefrontal systems responsible for planning and inhibition tend to work considerably less effectively, while reward signals can feel noticeably louder in comparison. Under real stress, the brain may prioritize immediate relief above nearly everything else, which makes any long-term goal considerably harder to hold on to in the moment. Blood sugar swings can add yet another layer of challenge here too, since low energy states can increase both irritability and urgency, and the mind starts actively searching for fast fuel or quick comfort as a result. This is exactly why simply trying harder so often fails on its own. The underlying conditions themselves are simply working against you. People tend to make their genuinely best decisions when they're rested, properly fed, and not already overloaded. That points toward a fairly useful strategy. Plan your harder choices for the times when your brain is actually well-resourced. Reduce friction around good habits, and increase friction around impulsive ones instead. Willpower, seen this way, becomes considerably less like some heroic, ongoing battle, and considerably more like simple, steady wheel steering. Protect your sleep, keep your meals reasonably steady, and self-control so often starts to feel less like wrestling, and much more like gentle, ordinary steering instead. A genuine sense of purpose, meanwhile, is linked with measurably better long-term health outcomes overall. Purpose can function almost like an internal compass. Studies have linked a stronger sense of purpose with a lower risk of early death and with better outcomes across several distinct health measures at once. Some of these pathways are fairly behavioral in nature. People with a clear sense of purpose tend to move more, keep medical appointments more reliably, and maintain routines that genuinely protect their sleep. Purpose may also change stress physiology more directly, though. When life feels genuinely meaningful, ordinary setbacks tend to feel considerably more manageable, which can reduce the overall chronic stress load carried day to day. Purpose was never required to be grand, either. It can be caring for family, building a craft, serving a community, or simply learning something that genuinely matters to you personally. It can shift over time too. Retirement, illness, or loss can each change it considerably, and that particular shift can feel genuinely disorienting when it happens. Rebuilding a sense of purpose, seen this way, can function as a genuine health intervention and not only as some abstract life project. When you wake up with a real reason to, your body often behaves noticeably differently across the entire day. It prepares more effectively, invests more fully, and recovers with considerably more consistency overall. And health, more broadly, tends to spread quietly through entire social networks, rather than remaining a purely individual matter. Friends genuinely influence habits, largely because humans learn so much simply by watching one another. Within social groups, norms around food, movement, and rest tend to spread quietly, almost without anyone noticing directly. If your friends regularly take evening walks, walking itself starts to feel normal to you too. If your workplace quietly celebrates staying late, sleep can start to feel somewhat optional by comparison. Research on social networks suggests that behaviors like smoking or gradual weight change can genuinely cluster within groups over time, shaped by shared environments and social norms alike. This particular influence can work either for you or against you. A genuinely supportive group can make healthy choices considerably easier by reducing friction and adding a natural layer of accountability. A high-stress group, on the other hand, can quietly normalize skipping meals or simply living on caffeine instead. The influence itself is often fairly subtle. It shows up in what you talk about together, what you invite each other to do, and what you each happen to praise. This means you can genuinely shape your own health by shaping your surroundings instead. Joining a class, finding a regular walking partner, or building a simple family routine can each meaningfully shift your own baseline. Health was never only personal discipline. It's also, in a very real sense, social gravity. Let's rest here again for a moment. Let your own thoughts settle the way a long day finally settles into evening. Nothing left to prove, nothing left to arrange, only this quiet moment, exactly as it already is. Let's turn, gently, toward medicine itself and toward the deeper, quieter idea of prevention before we finally bring tonight's journey to a close. Antibiotics genuinely save lives, and yet they can meaningfully disrupt an entire gut ecosystem in the process. These particular medicines represent one of the great turning points in the whole history of human health. A bacterial pneumonia that once killed quickly can now become entirely treatable within days. A deep wound infection can be stopped well before it ever reaches the bloodstream. And yet antibiotics don't only strike their intended target. Many also affect the helpful microbes living quietly in your gut, which can change digestion, immunity, and overall comfort for a while afterward. Some people notice diarrhea, bloating, or new food sensitivities following a full course. In certain cases, that disruption creates a genuine opening for more stubborn bacteria to overgrow instead, occasionally causing severe illness of its own. This is exactly why clinicians generally aim for the narrowest effective drug, used for the shortest genuinely effective time possible. It's also why properly finishing or not finishing a prescribed course is really a medical decision and not simply a piece of folk wisdom passed around casually. Antibiotics are genuinely powerful tools. Like any sufficiently powerful tool, They tend to work best when used with real precision and real respect. Even ordinary drug metabolism can vary enormously between two people, shaped by genetics, liver health, and whatever other medications happen to be involved at the same time. Two people can take the exact same dose of the exact same medication and experience genuinely different effects as a result. Your liver relies on enzyme systems to break down drugs, and those particular enzymes are themselves shaped by individual genetics. Some people process a given medicine quite quickly, so blood levels drop sooner than average. Others process the same medicine more slowly instead, meaning the same dose lingers considerably longer, and side effects become correspondingly more likely. Age, alcohol use, and existing liver disease can all shift this balance further. Then there are drug interactions to consider too. One medication can block an enzyme that another medication genuinely depends on, unexpectedly raising blood levels of the second drug as a result. Grapefruit offers a fairly well-known example here, since it can interfere directly with certain metabolism pathways and change how much of a given drug actually reaches the bloodstream. Even herbal supplements can matter, since some can speed up or slow down this same underlying breakdown process. This is exactly why an accurate medication list matters so much at every appointment. It's also why the exact same prescription can feel genuinely perfect for one person and genuinely miserable for another. Your body, in a very real sense, is its own chemistry lab, with its own entirely unique settings. Blood pressure, similarly, can look perfectly normal on a given day, while quietly hiding real risk that only becomes visible over years. A single reading is really just a snapshot and not a full biography. Blood pressure naturally shifts with stress, sleep, caffeine, pain, and even the simple timing of your last meal. Some people experience what's called white coat hypertension, where the anxiety of a clinic visit itself pushes numbers up temporarily. Others experience the opposite, sometimes called masked hypertension, where readings look genuinely fine in the clinic, yet run consistently high at home instead, especially during particularly busy days. Nighttime blood pressure patterns matter quite a lot here too. Many people's pressure should naturally dip somewhat lower during sleep, and when that expected dip goes missing, overall risk can rise, even if daytime readings still look perfectly acceptable on their own. This is exactly why home monitoring and ambulatory monitors worn over a full day can be so genuinely valuable. They reveal the true underlying rhythm of pressure across real, ordinary life. Over time, even mildly elevated pressure can quietly stress the arteries, the heart, and the kidneys all at once. The real danger here was never dramatic in nature. The danger is slow, accumulating wear. Managing blood pressure, in the end, is often really about noticing the underlying pattern early, then gently nudging it down through steady habits and medication when it's genuinely needed. Many diseases, more broadly, begin entirely silently, well before any noticeable symptom ever actually appears. The body is remarkably good at compensating, and that particular skill can sometimes hide real trouble underneath. Blood vessels can narrow gradually while you still feel perfectly fine day to day. The liver can tolerate real strain while quietly building up fat in the background. Some cancers grow slowly, with no pain at all in their earliest stages. Type 2 diabetes can develop gradually, while energy still feels essentially normal, right up until the underlying system finally can't quite keep up anymore. This entirely silent phase isn't some kind of failure of awareness on your part. It's simply how biology tends to work. Symptoms so often appear only once a given system has fully used up its own available buffer. That's exactly why routine checkups can matter, even when you genuinely feel healthy in every way. Lab tests can reveal rising cholesterol, changing kidney function, or gradually creeping blood sugar, well before any real damage has had a chance to accumulate. Screening can catch certain cancers considerably earlier too, exactly when treatment tends to be far simpler overall. The underlying goal here was never to live in constant fear of some hidden illness. The goal is simply to treat health more like ongoing maintenance, rather than emergency repair after the fact. Your body genuinely tends to whisper long before it ever has to shout. Listening early can change the entire shape of the story that follows. And prevention itself, it turns out, tends to work best precisely when it feels genuinely boring, steady, and repeatable. The most powerful health habits rarely look particularly dramatic from the outside. They look like a person who sleeps at roughly the same time most nights. They look like meals with vegetables showing up again and again, without much fanfare. They look like walking, stretching, and lifting, done in small, unremarkable doses that never really require any real heroism at all. This is boring in almost exactly the same way brushing your teeth is boring. And that's also, quite simply, why it works so reliably. The body adapts steadily to whatever it experiences repeatedly. Extreme changes, by contrast, can often backfire, largely because they're genuinely hard to sustain, and the resulting rebound can easily erase whatever progress was made in the first place. Steady, unglamorous prevention builds real resilience slowly, over time. It lowers the odds of injury, reduces ongoing strain on metabolism, and helps keep mood considerably more stable overall. It also creates genuine momentum of its own. Once one routine becomes easy, another routine quietly becomes possible too. Prevention was never glamorous in any real sense, and yet it remains deeply, quietly hopeful all the same. It means your own future isn't only something that simply happens to you. It's something you genuinely help shape through entirely ordinary choices that gradually become automatic. Let's slow all the way down now and gather the whole, wide picture we've built together tonight. Health was never really a row of separate buttons, each one entirely independent from the rest. It's a network where one small shift can genuinely ripple outward across the whole system at once. A steadier sleep schedule can improve appetite regulation, which can change your food choices, which can influence gut comfort, which can, in turn, affect both mood and energy. A short daily walk can ease joint stiffness, which can make movement feel genuinely safer, which can lower overall stress, which can improve sleep once again in return. These were never simply poetic chains, either. They're practical, measurable feedback loops. This is exactly why single, isolated solutions so often disappoint on their own. The body rarely changes through just one single lever. It changes through a whole set of small levers, each one quietly supporting the others in turn. This same systems thinking also explains why setbacks happen the way they do. A stressful week can disrupt sleep. Then cravings rise. Then movement drops off. Then confidence quietly falls along with it. The fix here is rarely punishment of any kind. It's simply restoring one single stabilizing node, a consistent bedtime, better hydration, or one short walk. When one node steadies again, the others tend to follow along naturally. Health, seen this way, becomes considerably less about fixing one isolated organ and considerably more about gently guiding the whole network at once. The underlying goal was never really perfection, either. It's resilience and recovery. Perfect health, in the strictest sense, is genuinely a fantasy, simply because life itself is never entirely stable. People get sick. They travel. They lose sleep, grieve real losses, and face unexpected stress along the way. Resilience is really the ability to bend without fully breaking. And recovery is the ability to genuinely return afterward. That means building habits sturdy enough to survive an occasionally messy day. It means learning to recognize your own early warning signs, things like irritability, sudden cravings, or noticeably poor sleep, and responding with real repair rather than self-blame. It also means planning for setbacks as a genuine part of the overall system, rather than treating them as failures. A resilient plan tends to include simple, reliable meals, a default walking route, and a bedtime routine flexible enough to travel with you wherever you happen to go. Recovery, in turn, includes rest, hydration, and a return to the basics, rather than any attempt to make up for lost time through sudden extremes. The body genuinely responds well to consistency, and yet it also needs, quite genuinely, a measure of forgiveness. When you focus on resilience instead of perfection, you stop measuring yourself by some flawless, unbroken streak. You start measuring yourself instead by how quickly you return to your own supports and how kindly you rebuild every single time after any disruption. As we come to the end of this long, gentle journey through health tonight, notice, for a moment, what we've really been quietly listening to this whole time. Not one single, isolated system, but an entire living network, constantly adjusting, constantly learning. We drifted from immune memory all the way to the simple chemistry of movement. We followed sleep as it quietly shapes both appetite and repair. We visited the gut and its own crowded, living ecosystem. We listened to the heart and to the nerves carrying messages steadily back and forth between it and the brain. We watched the body manage both heat and cold with quiet, practiced skill. We noticed how stress can speed certain processes along while slowing others down considerably. We stepped gently into the senses, into balance, pain, and perception itself. And we saw, again and again, how the brain quietly builds your entire experience out of raw signals and careful predictions. We explored the real power of community, of purpose, and of the small, ordinary routines that quietly compound over time into something considerably larger. And we arrive, finally, at one simple idea, sturdy enough to hold nearly everything else we've covered tonight. The goal was never perfection. It's resilience and recovery. Let your own attention soften now. Unclench your jaw, gently, without forcing it. Let your shoulders drop a little further away from your ears. Feel the quiet weight of your own body being fully held, without any real effort required from you at all. Let your breathing settle into a slow, easy rhythm, in and out, like a tide that has never once needed you to steer it. You've done enough for today. Your body already knows exactly how to continue its own quiet work through the night. The same patient, careful work it's been doing since the very moment you were born, and the same work it will keep doing, gently, long after you've finally drifted off. Rest now. You've earned it. Good night.